This video will help you with Warm-Up 13. By the end of this video, you will be able to add, subtract, and multiply polynomials. Take a minute to grab a piece of paper and a pencil so you can take notes throughout the video and solve some of the practice problems. I will be collecting and checking for your notes and Warm-Up 13A and B. Let's get started. A polynomial of two terms is called a binomial. So right here what we have is a polynomial with two different terms. The first term is 7 times x times y squared, and the second term is 2y. A polynomial with three terms is called a trinomial. The first term in the trinomial is 8x squared. The second term is 12xy, and the third term is 2y squared. The leading coefficient of a polynomial is the coefficient of the variable with the largest exponent. The constant term is the term without a variable. Let's take a look at an equation. In this equation, in this polynomial, the leading coefficient is 6. The leading coefficient, remember, is the coefficient, the number, of the variable with the largest exponent. This has the largest exponent, so 6 is the leading coefficient. The degree is 3. It's to the third degree, which is the power, third degree. The constant term in this polynomial is 15 because it does not have a variable connected to it. To add polynomials, you are combining like terms, and that is what we are going to be working on today. For example, if we wanted to add the polynomials 5x to the third plus 6x squared plus 3 to the polynomial 3x to the third minus 12x squared minus 10, we're going to start by using a horizontal format. When you set up a horizontal format, you're going to set it up in a horizontal way. On your piece of paper, I would like you to solve this problem as we go through it. First, you're going to rearrange and group the like terms. So if you can see here, I've rearranged and grouped all the like terms with the like exponents. So this is 5x to the third plus 3x to the third. They have like exponents of 3. And I put them in parentheses so I could show them in a group. Then I added it to my next group, which is my like terms of x squared. So I have 6x squared minus 12x squared. And then I will add it to my last group, which is my terms without a variable. So 3 minus 10. The next step is to combine the like terms. So 5 plus 3 is 8, so I have 8x to the third. The next one is 6 minus 12 is negative 6, so it's negative 6x to the second. And then 3 minus 10 is negative 7. So my final answer is 8x to the third minus 6x squared minus 7. Now we are going to add these polynomials using a vertical format. You may choose either of the two formats to use, whichever you feel most comfortable with. When we set up the vertical format, you're going to set it up like you would set up a normal addition problem. So you have to line up your terms in a column, in the same column. So this column is all your x to the third. This column is all your x squareds, and as you notice, we've left a blank in the top two because in those polynomials we do not have an x squared. These are the x's and then the terms without a variable. You are going to arrange the terms of each polynomial in a descending order with like terms in the same column, which is what I just showed you. Then you can simply add them up. So you have negative 21, positive 10, and positive 5. When you add them together, you get a negative 6. Here you have positive 11, negative 3, and positive 1. you get a positive 9. Here you have negative 7. And this last column, you have a positive 6, positive 2, and positive 5, which is 13. So your final answer is 13x to the third minus 7x squared plus 9x minus 6. So once again, you can choose either the horizontal format or the vertical format, whichever is easiest for you. Now we are going to subtract polynomials. So to subtract polynomials, first you're going to rewrite the subtraction as an addition problem by distributing the negative. So if you notice here, we have a subtraction problem. What you're going to do is to distribute this negative to each term. So a negative times a negative is a positive x squared. A negative times a positive is negative 2xy. And then negative times negative is positive y squared. Now you have an addition problem, and you can go about solving this the same way you did when you were adding polynomials. In this case, we're going to rearrange and group your like terms. So you have 4x squared plus x squared is 5x squared. You have negative 5xy minus 2xy is negative 7xy. And the last one is 2y squared plus y squared is 3y squared. And that is your final answer. So here's some examples, and I'd like you again to try these problems. If you would like, pause this video, try it on your own, and check your answers. If you still need guidance, follow through this video, and we will try some more on our own at the end. So for this, we've combined our like terms. In this case, negative x to the third is the only term with an exponent of a 3. Same with 2x squared, it's the only exponent with a squared exponent. Here we have our like terms of x and our like terms of terms without a variable. When we add them together, we have our final answer of negative x to the third plus 2x squared minus 2x plus 6. Here's an example with subtraction. Once again, if you can do this, pause the video, go ahead and solve it on your own, and then come back and check your answers. So here's our problem. The first thing we're going to do is rewrite the problem as an addition problem by distributing our negative. So this becomes x to the third minus x minus 5. Here we can add the two polynomials together by combining like terms. So we have x to the third plus 2x squared minus 4x minus 4. Now we're going to move on to multiplying a polynomial. To multiply a polynomial by a monomial, which is just a polynomial with one term, you're going to use the distributive property and the rule for multiplying exponential expressions. So for example, if we were multiplying 2x times 3x squared plus 2x minus 1, you're going to distribute 2x times 3x squared plus 2x times 2x plus 2x times negative 1. In this case, you come up with a final answer of 6x to the third plus 4x squared minus 2x. Remember, when you're multiplying x's, you add your exponents. So this would be x to the first times x to the second, which just is x to the third. Here's another example. You're going to rewrite it by distributing, so you have negative 3x squared to y times 5x squared minus 3x squared y times negative 2xy minus 3x squared y times 7y to the squared. And when you multiply it out, this is your final answer. Just a reminder, you are adding your exponents. All right, to multiply two polynomials, you're going to apply the distributive property. So, for example, here is our problem that we're going to multiply. You have x minus 1 times 2x squared plus x minus 1 times 7x plus x minus 1 times 3. At this point, you're going to distribute each of the terms. So 2x squared times x is 2x to the third. 2x squared minus 1 is negative 2x squared. Here, this next part, you have 7x times x is 7x squared. 7x times negative 1 is negative 7x. And then the last one is 3x minus 3. Next, you'll combine like terms to get your final answer right here. Two polynomials can also be multiplied using a vertical format. The way you do it is set it up like a multiplication problem. And you would first multiply the negative 1 and keep your sign. So negative 1 times 3 is negative 3. Negative 1 times 7x is negative 7x. Negative 1 times 2x squared is negative 2x. Then you're going to multiply x. X times 3 is 3x. X times 7x is 7x squared. And x times 2x squared is 2x to the third. Then you're going to add by 3x, you're going to add the term in each column. Okay? So when you add the term in each column, you get 2x to the third plus 5x squared. So you have to line up your terms. Minus 4x minus 3. It should be 3, not 3x. To multiply two binomials, you're going to use the method called FOIL, which we touched on earlier in the year. It's based on the distributive property. Just a refresher, the letters of FOIL stand for first, outside or outer, inside or inner, and last. So the first thing you're going to do is multiply the first term. Then you're going to multiply the outer term. Then you're going to multiply the inner term. And then multiply the last term. Then you're going to add the products together and combine like terms. So here's an example of foiling. Here's our problem. We're going to multiply first, so 2x times 7x. Then outer, 2x times negative 5. Inner, 1 times 7x. And last, 1 times negative 5. Then you're going to, which is demonstrated right here. Then you're going to combine your like terms. Negative 10x plus 7x is negative 3x, and that is your answer. Here's another example. If you want to pause the video, try it on your own, and then come back. You do the same thing. You're going to multiply your first, then your outer, then your inner, and your last. Add them together, combine like terms. And in this case, you can rearrange your x and y so you can combine your like terms because it's just a multiplication. And you get your final answer. Here's an example with a rectangle. So the length of the rectangle is x plus 5. The width is x minus 6. To find the area, you're going to multiply your length times your width. So this is a foiling problem. Your area is length times width. So the length is x plus 5. The width is x minus 6. When you multiply them together, you're going to FOIL. So x squared minus 6x plus 5x minus 30. Combine your like terms to get your final answer. X squared minus x minus 30. So that is your area. And when you label it feet squared. That is the end of our video today. At this point, you should complete warm-up 13A and 13B and be ready to review this in class. If you need to review some more, you can go through this video again and take some more notes and solve some of the problems.